Hi, I'm Anthony Magnabosco, and I took a left at the Valley.
You sure you didn't get lost at the Valley?
I know we shouldn't have to scream that we're atheists. You know, we don't have non-astrologers and all that. But with the religious people taking over the world, I mean, we can either speak up or be pushed into a corner.
I'm proud to be an atheist, a skeptic, a non-believer, an infidel, a heathen. I call it how I see it. I say it's ignorance and you just call it faith and unsubstantiated claims. That's something to be ashamed. I'm an atheist.
Coming at you with the Mayflowers, this is Left of the Valley. My name is Kevin, and I'm told there's a perfume with no smell whatsoever. I think it's nonsense. Joining me as usual is a team that started with nothing and they still have most of it. Her prophecy class was canceled due to unforeseen circumstances. Nancy.
Absolutely.
And she's reading an anti-gravity book. She couldn't put it down. Christina.
It was a very good read.
And she slept for 6 hours straight and 2 hours gay. Kirsten.
Yeah, that sounds about right.
How does sleeping gay feel? How does that happen? Ladies, welcome back. Hope you had a great week. Hope you're not too banged up from your trip there.
Christina. Hi, I always stick the landing.
Nancy, welcome back.
Thank you. It's good to be back. But
back in the,
a weekend in Devil's Lake with the family was just
Devil's
wonderful.
Lake.
Devil's Lake.
You say that, but we all know it was a convention of killers. We all know.
Yeah, totally.
Devil's
Yeah.
Lake, come on, let's face it.
Yeah, it's great when an atheist goes
You
to
don't have
Devil's
family at Devil's Lake.
Yeah, an atheist should have a family at Devil's Lake, right? It should be Satan's Lake, but that's okay.
So today we'll be talking to our old friend, nuclear physicist Dr. Ben Davis, and we'll be talking about the difference between physics and quantum physics.
Oh, it's going to be such a good combo.
But first, let's do a bit of chit-chat. So, there's a review in the Theoretical and Applied Climatology found that, you ever heard that, when they say 97% of all scientists agree about climate change, and there's 3% that apparently don't? Mm-hmm. Well, apparently,
I didn't realize it was that high, 3%. That seems a little high.
Well, apparently those 3% that don't agree, deny climate change, they reviewed their work. And they tried to replicate the findings, and it's only yielded faulty bias outcome.
Oh, what a surprise.
Who would have thought, Mm-hmm. Apparently over 38 papers over 10 years, actually, and they found they have a whole bunch of mistakes that show clear bias. So I don't know who these so-called scientists are, but either they do crappy work or they're kind of paid off to...
Or a combination of the two.
Yeah, exactly.
And they can't write worth a damn either.
So I have just a clarification question with that. Is it 3% of scientists don't believe climate change is happening, or that it's like human caused?
Well, that's a good question. That's a good question. The article wasn't specific enough to say about that. I think it'd be 3% of them saying it's not happening.
Oh, okay.
Because, that second volley is what happens once the science is overwhelming. And then they say, well, okay, fine, it is happening, but it's not human cause.
Yeah, totally.
It's the second answer, right? Moving on, the World Health Organization, the WHO, says it no longer recognizes transgender as a disorder.
Oh, it's made me so
I saw
happy.
that.
Yeah, and thank goodness for that. I mean, for the longest time, it's been one of the arguments against transgender people. So, it's a mental disorder. I've heard that argument over and over again.
Same.
So Human Rights Watch says that the changes will be actually profound. Dr. Lace from the WHO says that we have a better understanding that it's not a mental condition, and it basically... Right now, they're recognized worldwide, I guess, and it should change also. I don't know if the DSM-5 has transgender as a mental condition or not.
Gender dysphoria.
Yes, that's what the argument that's often used. Mm-hmm. But now, I guess they have to rewrite the book.
Well, that goes along with what Dr. Drance has told us many, many times, that it's a spectrum.
Exactly.
And finally, they've put transgender people on the spectrum of normal human sexual behavior. Mm-hmm. Is it sex? No, gender? Well, whatever. It's on the spectrum of normal human behavior.
Do you guys remember when the U.S. decided to go to war against Iraq way back then, and the Canada decided no, and the French decide no, and then they decide to relabel French fries as freedom fries.
Yes.
Wait. They did what?
Yes. Instead of calling them French fries, because France, they give them a big emphatic no. And at the time, the U.S. responded by saying, well, we're no longer going to call them French fries, like they're French for some freaking reason.
Oh my god!
And we're just going to call them freedom fries, right?
America's so weird.
You don't remember the freedom fries?
Well,
My memory is horrible.
well, now the Mango Mussolini Trump regime decided to rebrand gas exports, like natural gas,
Oh, I heard
to
this.
freedom gas.
Surely you can't be serious.
I am serious. And don't call me Shirley.
Molecules of freedom gas.
Really?
Yes. They
Freedom
say
gas?
it's to promote clean energy, like clean coal, I guess. Of course, every environmental group has been decrying this, saying, come on, you're not fooling anybody with freedom gas here. So I don't know. If you start farting, maybe you should call it freedom gas to you. I'm just passing freedom gas. Now, quick anecdote on that. It was so funny because, being French Canadian myself, I remember having these arguments in the U.S. And I remember this guy coming at me and he says, this is no word of a lie, right? He says to me, listen, because we're boycotting your French fries, like somehow they're my French fries, and he thought a French Canadian meant French from France, obviously. Fox News, red flag, told him that apparently the economy of France was $7 billion in the hole because of boycotting French fries.
Oh.
I said, really? I said, yeah. So let me explain a few things to you, bud. I said, first of all, they're not called French fries in France. They're called potato fries, right? And French toast is literally translates to golden bread.
Oh my gosh.
And French mustard, I believe, was an American company at the time. So you're kind of boycotting yourself there, doofus. But, that's what happens when you do these kind of people. Speaking of Mango Mussolini, did you guys hear that while he was visiting Japan, the White House asked the Navy to hide the new destroyer called John McCain? John McCain.
They're actually investigating. It's a big scandal now. It's a jaw dropper.
Now, apparently, this is not an order from Trump himself, but
No.
the White House is so afraid that Trump is going to have some kind of tantrum that they're trying to hide a freaking boat from the
I know.
man.
It's just unbelievable that the fear of his wrath, or the fear of being fired, or the fear of whatever it is that's running our country now. A madman's fear,
Yes,
a madman's preferences are now what's running our country.
The U.S. is being
The
brought
US
down
country.
by not even a strong man, an incompetent buffoon of a madman. That's even funnier. That's what's so funny about this. He's not like a strong-armed general that'll behead you.
No.
And I can understand why people would be afraid of that. He's a guy who won't even remember your name 3 seconds after speaking to you, that doesn't know the difference between HIV and HPV, and somehow people are deathly afraid of this man. I don't understand what's going on.
Well, I guess you just have to look through history at the madmen who have been the dictators or the kings, and you see the parallels of how everybody shrunk away, from his orders and just did what they thought he wanted in order to have some peace and quiet, I guess, in the office. But when you think about the United States being one of the leading democracies of the world, and that's what it's come to, that one, and I can't say the Republicans 100%, but that is where the government now gets its guidance. How is Trump going to react to this?
It's amazing.
It's a bad movie and a terrible novel.
Yeah, it is. Yeah, it would. Years ago when they tried to make that movie about these two American actors killing Kim Jong-un, and they made this huge scandal.
The interview.
Yeah, you can almost do the reverse now, but do something like that about Trump. People are so afraid of talking to him, but they send these two buffoons. Oh, whatever. So anyway, the Navy says that the name of the ship was not obscured for the visit. The Navy says, no, this didn't happen, but they were requested to do so. But, however, some sailors from the John McCain were actually refused entry to hear Trump's speech.
Well, there was also a tarp put down on the front of the ship, whether that was because of the repairs or it just happened to be there.
Yeah, I absolutely amazing.
It is.
But at the same time, and maybe we should ask that, is the reason they send Mike Pence up here to Canada is because, Trump refused to come to Canada because we have McCain fries?
They're so good.
You know,
I'm not coming up there unless they get rid of those damn fries.
Okay, who's got a big slingshot?
The only saving grace at this point is investigative journalism.
Yes.
If there
And
are
they're not really doing their
restrictions,
job.
if there are restrictions put on the free press, all is lost.
Yeah. Oh, it's absolutely amazing. It's like comedian Bill Maher said it best. It's like a slow-moving coup. It really is that.
Mm-hmm.
I mean, this week they had that Mueller basically make a press announcement.
That was amazing.
He basically gave him everything. And it's like, at this point, it's like, if this was anybody else but the president, this person would be in handcuffs right now and thrown into jail. And he gave him everything they need, and yet nobody's moving. It's like everybody's looking at each other and say, okay, what do we do now? In the meantime, Trump's doing whatever he wants. It's just absolutely amazing what's going on in that country right now.
I know. Unless there are more Republicans that come on board, it's a dilemma.
Oh, it's huge because it seems the Democrats don't have the spine to do anything, and the Republicans are too scared to do anything too. So it's like you're in this I don't know, this phantom zone of nobody's moving, but everybody knows this is wrong somehow. But, you know, and in the meantime, the crooks are taking advantage of it.
Well, I think a lot more is going on behind the scenes. At least I hope that's true.
Yes.
And his financial records have been demanded. I mean, the subpoena has been honored. So it's a matter of time before all this comes out. I really think that what needs to happen is what exactly happened during Nixon's impeachment, in that the American public needs to be educated as to what is going on. Nobody's going to read the Mueller report except news junkies and the politicians and the journalists. It has to be put on TV and dumbed down so that people say, this is what the crook did.
Yeah, but it seems that 30% of the populace is agreeing with Trump no matter how stupid he says.
But that's not enough. That's not enough to win an election.
No, but that's exactly it. It seems like nobody wants to move until there's an election, which is just absolutely amazing because somebody should have moved by now and done something.
But I think the education, if they do it, because it has to be in pictures and on TV and in short
pop-up
bursts.
books.
It really does. And then the people who are being harmed by the tariffs and the people who are being harmed by the healthcare cuts, they will begin to understand that a vote for Trump is a vote against their self-interest.
Yes.
But it's not going to happen unless the hearings are on TV. I think that's enough time for this jerk, don't you?
He's been there 2 years too long, if you ask me.
Yeah.
4 years too long. Yeah, so I guess we won't see Trump up here because we got McCain fries. So I hope they serve him a nice poutine.
Thank you,
McCain. Nice poutine with McCain fries. Speaking of Mike Pence, like I was saying there, so the Prime Minister is to meet with Mike Pence and to discuss the regression of women's rights. He's very concerned about the states. We've been talking about this for the past couple of shows, about abortion rights being basically taken back. There was an MP, and like I said, for the past 3-4 shows, we've been discussing this a lot. And, I've been saying, just keep an eye out because the conservatives are going to try to do the same thing up here, right? And right this week, told you so, an MP, which is Monique Posey, made a motion related to abortion. She basically said we should make a motion to reaffirm that a woman's body belongs to her and she has the right to choose, which is
good.
Of course. Good. Right, it's good. And of course, the Liberals... the Liberals rose, the NDP rose, the Greens rose, the Bloc Québécois rose, the Independent rose. Who didn't?
Conservatives.
Exactly. The Conservatives sat down on their hands and didn't do a damn thing. And I told you, and this is exactly, and people are telling me, no, this is not going to happen, Kev. It's not going to happen. This is Canada. God damn it. Don't be complacent about this.
Yes.
Don't be complacent about this just because you think you're protected under the law. You talk about lawmakers, they can try to change the law, and they will try any sneaky way to do it. Christians are always on the offensive. Yeah. How many times I have to drill this into people? And just because this is Canada and not the U.S., don't think that it can't happen here. Anyway.
Yeah, I definitely think one thing to take away from that is if they do get into power this next election, they will try.
They will try.
Because they'll be emboldened by the states and be like, oh, look what they're getting done.
Exactly. And we've been saying this for almost years now in this very program. Now, like I said, the leader, Andrew Scheer, is not going to do it himself because that's political suicide if he tries that. But he's not going to stop his backbenchers from trying to bring the motion forward. and then he's just going to try to see where it goes. They always remember Stephen Harper. Remember Stephen Harper? He started at some point to say things like "God bless Canada." He started saying that.
Seriously?
Yes, because he started to make. They always do this. The conservatives always do this. They take a page from the Republican book in the States. They try to apply it here, and they see how people react. He started saying "God bless Canada," and what's this idiot's brother, Doug Ford? What was the other one? The one that died.
I don't remember.
More on there, overdose, whatever. The other Ford started doing the same thing. God bless Toronto. The thing that stopped them is the reporters were laughing at them when they said that. Then they stopped. Then they let time go by. They wait. Now they're trying to bring those tactics back. You just watch. If a conservative goes in, he's going to start saying the same thing. God bless Canada. And just wait to see how people react. And if the reporters don't mock him and don't make a peep about it, then they're just going to push it more and more and more. Little pushes, but they're always on the offensive. And you mark my words about this. I told you. Anyway.
So, as a note to reporters, that happens. Laugh.
Yes, do laugh. Oh, and last thing about that little abortion thing. The province of Quebec said it would ensure access to late-term abortion in the province as well. So, in Canada, hopefully the provinces are going the other way.
I think there's an alert, but I think we're okay.
Well, I hope so. I hope so. But like I said, let's not be complacent about this.
No, it has to be. We all have to be on top of it. But I think we're okay.
Yes, I hope so. Yeah. I hope so. But I mean, let's stay vigilant. Anyway, my dear Nancy, you got a top 10 for us?
I have 2 top 10s.
Way better than the one I did last week for you.
No, you did a great job. The reason I have 2 top 10s is actually I have 1 top 10 divided into 2, and you guys are going to choose which part you'd like to hear today and which part for next week. It has to do with candy. Ooh. What are the most popular candies in the U.S. and what's the most popular candy in Canada? So which would you like to hear today?
Canada.
Canada?
Okay, sure. I've been outvoted Canada.
How do the puppies... We have puppies with us today.
I know.
Do the puppies get a vote?
They want Canada.
They want Canada?
You can't speak for the puppies.
Oh, yes, they can. They're the mommies.
That's 4 against 1 then.
You weren't going to win that.
No, I'm never going to win anyway.
Okay, here we go. We love Canadian candy, eh? Oh, boy. Yeah. Okay. People in Canada like the American candies, but we have a special regard for the ones up here. So here we go. I don't know whether we should tell our American audience there are some candy. Are we talking like chocolate bars and stuff like that? Or? We're talking about pretty much the different types of candy. What you might not know is there are some candies that you guys have in the States that we don't have up here, and vice versa as well. That's right. Yes. So this is going to be new to some of our American and those in other countries. That's right. But most of these candies you can order on Amazon and have shipped to you because there's nothing restrictive about on any of the list for candies.
Except Kinder Surprise.
Kinder Surprise.
Well, we laugh, but we have to explain that now because what the Americans' friends don't understand. Kinder Surprise is basically a chocolate egg, and there's a little capsule inside the egg with a toy for a kid. But American borders don't want you to cross over with these because you can hide something. I guess you can remold a chocolate egg, and you can hide something in the capsule, and they're usually afraid of nuclear terrorism or something like that.
Well, that's not the reason they're illegal in the States.
Yes, no, what?
No, it's illegal because there's a law saying that you can't, if there's a law in the States that you can't have toys in food because it's a choking hazard.
No, it's not the toys in food, it's the choking hazard.
Yeah.
Really?
Yeah.
Oh, see,
it's too small.
Okay.
Yeah,
because
that's why it's illegal.
That's funny because that's not what when I've talked to border agents, that's never what they've told me.
Yeah.
So, okay, no, we get 2 reasons apparently.
Yeah, it's a choking hazard for children under 3, and those...
What they're doing, just shoving the entire egg in their face at the same time?
Well, no, they usually involve like really tiny pieces. Yeah. Like there's puzzles sometimes with really tiny pieces. And
yeah, that's really interesting. Okay, number 10 in Canada, Maltesers.
Those are pretty good.
Anybody like Maltesers?
I don't know.
They're kind of like Whoppers.
I've never.
I haven't had them for a long time, but I have had them.
They go back to the 1930s, and they're little balls with crispy malt honeycomb center, and they've got milk chocolate around the top. That's why they're number 10. They're not the most popular, but they are really popular. And the way they chose which ones are the populars by sales. So
Okay,
that's how, not by taste, but how many sales. So this is number 10, really, in Canadian.
They're nice and small and easy to just pop in your mouth.
Yeah. Okay, number 9. This is one I haven't tried. Palamine. Have you ever tried Palamine?
I've never even heard of it.
I haven't even heard of that.
No, it's
Maybe
a Canadian
it's
chocolate bar.
East Coast?
Maybe.
This goes back to 1873.
Wow.
It's the oldest candy company, and it's in New Brunswick.
Yeah, there it
It's a
is.
Canadian chocolate bar with a rich fudge center, and then it's got coconut, peanuts, and premium dark chocolate.
No.
Sounds delicious.
Sounds good,
No,
actually.
thank you. There's like 3 things in there that I do not enjoy.
Yeah.
Coconut and chocolate.
Yep.
Yeah.
What's wrong with you?
So
I'm
okay.
weird.
Yes, you are.
The texture of coconut.
But we love you nonetheless.
I know.
Yeah. Okay, so now we come to Thrills Gum.
Oh, the gum that tastes like soap.
I'm sorry.
It's manufactured in Ontario.
Yes.
Oh, that's why.
It's,
And
it's an old gum, but if you pop it in your mouth, it actually tastes like soap.
That's so gross.
It's amazing.
It's like the classic nostalgia soap taste, isn't
I
it?
like
Yes.
I like the name of the company that started it, the OPG company.
The OPG company,
And then
yes.
Nestle's brought them out in the 1980s. It's a purple gum, and it has a sweet soap-like flavor.
Yes, it does.
That's right. It's really an odd acquired. So you have an odd
Oh,
acquired.
I do
taste
have an
along-
autocorrect. The first time you try that, I said, "What the hell is this?"
So-
but you know what? Now it's like, "Oh wow!" As soon as I see, you often see them, but when I see them, I have to buy them now. It's like, "Oh yes!"
So when was the last time you had Thrills Gum?
I had a pack here last week that I
You
finished.
did?
Yes.
Ah, okay. So that might be an interesting choice for somebody to order. That's really kind of different and unique.
Yes.
That comes from Canada.
People are listening to this. Gum
Okay.
that tastes like soap. What's wrong with those
So,
Canucks?
yeah.
God.
Okay, number 7.
That's why we're so polite, right?
Yeah, we are.
Clean
Number
mouth.
7. Da-da. Smarties.
Oh yeah.
You know, I liked Smarties, and I'm pretty sure at some point they changed the formula for their candy coating because I no longer like Smarties.
Yeah, they probably did. Well,
Might have also just been
Americans don't have
changed.
Smarties.
Well, they're like M&Ms
Yeah,
to the
exactly.
Americans.
They're like
and they were
M&Ms.
originally called Rockets. I didn't know that.
Yeah,
Yeah.
that's true.
Wow. So, but these are the real candy coated.
They're older than M&Ms too. They came out way before M&M. I'm pretty sure.
Yeah, I don't know exactly when they. I didn't in the research. I didn't see, but they are the retro Canada, and everybody loves them. And most people eat the red ones last. I don't know why.
I don't have any preference for colors.
I usually go for M&Ms.
Yeah. Well, there's really a debate as to every now and then you see a debate M&M or Smarties, but they all come up in the top 10.
Yes.
People really like
Yes.
them. Okay, number 6, Coffee Crisp.
That's another chocolate bar the Americans don't
I've
have.
actually never enjoyed Coffee Crisp.
Oh, they're not one of your favorites?
No.
That's the one thing that's coffee flavor I enjoy, actually.
I love Coffee Crisp.
These are from 1939,
They're
and
so
for
good.
anybody that doesn't know, they're a light and crispy wafer sandwiching a coffee-flavored filling between the layers of the chocolate, and then it's covered with chocolate. I like them.
That's
I
probably what started my coffee addiction.
Yes.
That was it. I think when they advertise it, if you need a nice light snack, so it's appealing because you figure you're not going to be 900 pounds after you eat 2 or 3 of them.
Didn't they have that advertising? How do you like your coffee? I like my coffee crisp.
Coffee, oh yeah.
A little
Yeah.
crisp.
That's when I bring candies down to the States, I always include the coffee crisp.
Oh, yeah,
and
of course.
everybody. I don't understand, but they don't have anything really like that in the States. Number 5, Aero bars.
Yeah, that's
So good.
Wow, I also don't like Aero bars.
That's because that is pretty much pure chocolate, which you don't like.
No, I don't.
No, but this goes back to the 1970s. It's bubbly, it's smooth, and it melts in your mouth. And if you've ever seen the ads, they're really cute with the bubbles and the melting in your mouth.
They make really fun ads.
Now, actually, with Aero Bar, it was introduced in the States, but it just didn't deliver the wow factor that Aero has for the Canadians. So they're not. I don't think you can find them in the States, but you could always order them. They're good. Number 4, Maynard's Wine Gums.
Oh,
I think I've heard of those.
I've had them before.
I don't think I've ever
They're
had them.
sort of like gumdrops, but without sugary coating.
I feel like I've eaten them.
They're like gummies,
I can't
huh?
They're like
remember.
gum, and
Yeah.
they're like wine.
They're
like-
gummies, but they're not
they're
like
gummies.
as sweet.
Yeah.
They're a little bit more kind of on the bittery side.
Yeah, they've been around since 1896. So obviously, enough people like them to put them at number 4. It's a long time for
Yeah, for a candy to
Do they
exist.
sell them in Costco? Is that where I've had them?
Costco sells everything.
It does.
Okay, number 3, Big Turk.
Oh,
I don't think I've ever had a Big Turk. I've seen them.
I haven't. I've seen them,
I haven't
but they're
had one.
exclusive to Canada, and they're kind of like the Palom. They're exclusive to certain taste buds, and some people think it's a required taste, and they do love them. But the middle of them are filled with like a Turkish delight type of.
okay.
It's like a gummy textured candy with sort of a reddish purple hue, and then it's covered with rippled milk chocolate.
Yeah.
So some people think that it tastes like chocolate covered red licorice, but other people don't. So it's one of those.
Don't think I ever
if you
had
like it, you like it. If you don't, you're never gonna taste
So
it.
far, it seems Canadians have weird taste in candy.
Yeah.
So far.
But people who are on a diet like them because they're 60% less fat. But if you don't like the taste, who cares?
Yeah, exactly.
Okay, number 2 is something I've never had either, called Eat More.
Oh, I've had those.
I don't think I've
You
had
had
these
those?
either, but I've seen them.
Yeah.
It's like dark toffee, roasted peanuts, and chocolate.
Yep.
It's chewy and
Oh,
firm,
yeah.
and
Yeah,
it's
it's
a
got-
retro bar.
Yeah, it's got a yellow and green packaging. Yeah.
Yeah,
I don't think I ever had that one either.
No,
They're
it's
really
unique,
good.
But it's number 2 according to sales, which is kind of interesting. Okay, who wants to guess what number 1 is?
Oh, God.
I actually
I know
have
Kit
no
Kat
idea.
came to mind,
Yeah, I would have thought so.
I would have thought that.
especially since their bars are giant now.
Yeah.
I would have
yeah.
thought that toffee, butterscotch toffee bar.
I'm
thing.
gonna guess
Macintosh?
Yes.
You're right. Absolutely.
I love
yeah,
Macintosh.
Macintosh is a long history. They've been around since 1890. And they're one of the favorite old-fashioned Canadian candies. It's like a solid slab, and the packaging is really distinctive. It looks
Yes.
like something Scottish, and or tartan design.
Yep.
And one of their sayings is "Smack your Mac."
Smack
It's a
your
toffee.
Mac. I love that.
But yeah, I've had relatives that have been addicted
Oh, yes.
to Macintosh, and I've sent them, sometimes they're hard to find. You have to go 2 or 3 stores sometimes to find them.
There's a store in Mission, right by the Leisure Center. It's like a little corner store. Macintosh. I'm pretty sure they've got them there.
Oh, okay.
Okay.
They also
Any
have them
other-
at
any
Superstore.
other-
They do have them at Superstore.
Any other than Kit Kat? Is there any Canadian candy that you guys like that's not on the list? Since all lists are, this is by sales, but that doesn't mean.
I don't know if it's Canadian specifically, but Charleston chews are pretty good.
No, that's got to be American. Charleston's shoes. It's got to be American.
It's got to be American, but they're still good.
Well, see, I'm not much for a candy person. I'm
I'm not a candy person.
I'm more of a pastry and cake kind of guy.
Yeah.
So
And-
I could talk about that, but I'll have to bow out of that one.
Yeah.
And few things are going to stand up to the bonbons.
Oh my gosh, bonbons are the
Bonbons are the best.
Bonbons.
They're English though.
Yeah, they are.
Okay, so next week we'll
Perfect.
do the American candies and see how many of us Canadians are familiar with the American candies.
Yes, that should be interesting. They do have some American, some candies in the States that we don't have up here, and once in a while when I go in the States, I try to stop by and grab something that
Yeah.
we don't have.
But I think proportionately in Canada we have more of the American candies up here than the.
Oh, for sure,
Canadian-
for
yeah,
sure,
yeah.
for sure.
So
Absolutely.
they should be familiar to most of us next week. Okay,
So,
part
enjoy your
2.
sweet tooth until next week.
Yeah.
All right, my dear Kirsten, you're ready to give us another brilliant moment?
I certainly am.
Brought to you by religion.
All right. So, nearly a year after the army decided a Norse pagan heathen was allowed to have a beard under a religious exemption that also applied to Sikh soldiers, they've denied a similar request from a self-proclaimed pastafarian. Is it pastafarian or pastafarian?
It depends which sect you're part of.
Either way, Lieutenant General Thomas C. Stevens rejected a request by Army Specialist John Hoskins.
Which
who's-
army is this? Canadian or?
I believe this is American.
This is American military, okay.
Yes. Who said he was motivated by the flying spaghetti monster to grow a full beard.
And become a pirate.
Funny you mentioned pirate. Hoskins wanted to see how far the Army would go in the name of respecting religious beliefs, according to the Army Times. This request is based on my deeply and sincerely held belief in the pastafarian faith, Hoskins wrote in his request to the Army. It is my personally held belief that growing a beard will bring me closer to my God and bring me into his favor. Hoskins even had support from the church itself, which said in a letter that the Army should grant his request. The Church of the Flying Spaghetti Monster has always affirmed that reasonable measures be taken to allow pastafarians to practice their beliefs, the letter stated. This includes, but is not limited to, the consumption of alcoholic beverages during personal hours, the growing of facial hair, the keeping and care of parrots and other birds of paradise, and the overuse of the word "arr." Thank you for your cooperation, and may you be touched by his noodly appendage.
See, the thing is, I totally understand what they're trying to do, but there's one thing they can always kind of get you on. When somebody says, it's my deeply and sincerely held belief, it's not sincere. Let's face it. We're not. You're an atheist. You don't truly believe there's a flying spaghetti monster, and this is where they kind of gets you. But I understand, trying to stretch the limit of where it goes.
The Army came to the same conclusion you did in calling him out, saying that it wasn't truly sincere, and that's why they denied his request.
Yeah.
Because of lack of sincerity.
So they would almost need to invent a religion that's crazy enough to be believable, but of course the FSM is, too crazy. It's just too nuts for even somebody to believe it. But then again, when you compare to some of the myth of other religion,
like virgin birth and
walking on water, and
exactly,
right?
That's, you can have that as a sincerely held belief.
Yeah. I mean, if the flying spaghetti monster was maybe more human in appearance, then maybe people would actually, but because it's a lump of spaghetti with meatballs.
Flying spaghetti monster. My favorite part in this is the letter that the church sent to them.
Yes.
And may you be touched by his noodly appendage.
This week I was having this argument. We had this fake argument on Facebook because some guy put down that somebody who's a pastafarian was refused a driver's license because he had a plastic colander on his head.
Oh my God.
And I said, blasphemy, it needs to be stainless steel, obviously, because, then we're having this debate. He says, no, you're taking it out of context. I said, no, pirates would not be using plastic. It's obvious that stainless steel is way closer to the original metal that the colander were made of. And we had this back and forth. It was absolutely hilarious, but anyway, I digress. Please continue, my dear.
That is all for today.
No, that's all you got.
Keeping
Okay.
it short and sweet today.
Short and sweet.
That was a good one.
Yes, indeed.
Short and sweet to go along with the top 10. Thank you.
Perfect. All right. So let's take a quick pause, and when we come back, we'll be talking to our favorite nuclear physicist, Dr. Ben Davis.
Yeah.
So stay with us.
Hi, I'm the Supreme Irreverend Dr. Randy Tyson from the Legion of Reason Diversion. Join me and my co-hosts, Christine Shelska, Twyla, and Nate Phelps, as we explore issues at the intersection of atheism, humanism, and skepticism. Topics range from alternative medicine to the interference of religion in public policy. We often have special guests to help us understand the topic du jour. Previous guests include biologist Jerry Coyne, ex-Muslim author Ali Rizvi, philosopher Peter Boghossian, and the late physicist Victor Stanger. You can watch us on the Legion of Reason YouTube channel or subscribe to the audio version through your favorite podcatchers such as iTunes or Stitcher. And don't forget to like the Legion of Reason Facebook page.
What's up, heathens? I'm the Godless Engineer, and it would be great if you could join me on my YouTube channel. Over there, we post videos every day. On Mondays, we normally post a response video of some kind. Tuesdays, we post our daily Bible podcast that I record with KC. Wednesdays, we read comments. Thursdays and Fridays is conspiracy theory and flat earth stuff. And we have a new segment that runs Tuesdays, Wednesdays, and Thursdays that is Today I Learned from KC.
Hi, y'all.
So please join us over on the YouTube channel Godless Engineer, where we always stand up and use our voice.
anti-Semitism was preached as an official doctrine of the church until 1964. Do you think that might have something to do with public opinion in Austria and Bavaria and Poland and Lithuania? That the Jewish people were accused collectively as a people of deicide, of the crime of the murder of God in the figure of Jesus of Nazareth. And that anathema on them was not lifted until 64, well after the perpetrators of the Holocaust had stood trial in secular courts and been rightly punished for their actions. How can this church say it has any moral superiority? It has difficulty catching up to what ordinary people regard as common moral and ethical sense, and it still can't make itself apologize properly.
All right, our next guest is a return champion, our favorite nuclear physicist, and the author of Ask Dr. Ben on Facebook. He's a snappy dresser and a snazzy dancer, Dr. Ben Davis. Welcome back to Left of the Valley.
Returning champion. I like that. Thank you.
Oh, perfect. We're so glad to have you back. It's always a pleasure to have you, Dr. Ben. Maybe for those who missed you last time you were on the show, maybe be so kind to give us a quick bio as to who Dr. Ben is.
Well, Dr. Ben is a very storied character. I got a PhD in nuclear physics, 400 years ago, back in the Dark Ages.
When dinosaurs roamed.
Couldn't get a job as a nuclear physicist because, that's not exactly a trendy thing in the workplace. So I was a college professor for a few years. Then for about 20 years, I became a software developer. And then I changed my career again when I got bored with that and became a controls engineer for a while. So the one thing about the physics, it definitely gave me some flexibility in terms of my career and learning to do new things. And now I'm semi-retired and back to being a college professor part-time.
Fantastic. So today we are going to be talking about what's the difference between physics and quantum physics.
Good
now,
question.
if I say something like the quantum consciousness of your inner body ends up in the quantum realm. I'm using the word quantum a whole lot here, like Deepak Chopra. And I think the point is, a lot of people hear the word quantum, they're familiar with the word quantum, but they have no freaking idea what it actually means. So we're hoping today you can give us a good distinction between the two.
Well, it's a good thing you asked me that question as a hypothetical. Because usually when people start talking that way, I usually start cursing like a sailor, saying really rude things to people, because that is such a misrepresentation of what quantum physics really is. And some of this goes to like the parallel universe. We won't call it, they call it a theory. It's a very loose theory, right? Parallel universe interpretation. Every time something measured in quantum physics, one atom's measured in an up direction and one atom's measured in a down direction, and the interpretation is the universe splits, and now there's two paths in the future, where the atom was measured up and the other atom was measured down, and so it split the timeline, and that happens. If that were true, that happens, billions of times every day, at the very least. And so every time that happens, it spins off a parallel universe. Then, our thought processes, because the brain's such a fuzzy thing and such a hard to understand thing, we might actually get ideas or visions from these other parallel universes, and that may be how we're mediums, and can talk to the dead, or how we're psychics. And okay, that's all bullshit. So even by recapping it makes me want to stop and say, don't believe any of that, right? Because first of all, that's a highly theoretical. The whole parallel universe interpretation thing is highly theoretical. There's no way to prove it. And secondly, you don't change the world just by measuring a particle. So this whole, and this then spins on to Mr. Chopra, who tries to tell us that if we just think happy thoughts, we can make the universe a better place. It's a lovely thought, and that's part of what I'm also kind of a semi-famous skeptic too, right? That's part of what makes it appealing, is because it sounds so nice. That if you just think happy thoughts, you can make the world a better place. We would all love to believe that, me included. But that's not the way the world works. as I like to say, the universe is a cold, impersonal place, and it really doesn't give two damns about you. You know, all we really got is each other, and that could be enough, but it's not because we thought happy thoughts and we changed the universe writ large when we did it. It's because we decided to be nice to one another.
So right off the bat, the law of attraction that says, you know, you do nice things, that'll attract nice things back to you, that's bullshit, essentially.
If you're talking about kismet or something like that, absolutely. If you're talking about a psychological effect where if you treat people nice, they treat you nice in return, I think that's true. Yeah. But, you know, but as far as, you know, what's karma coming back, you know, I can't buy it. You know, there are bad people that got to be bad people and enjoy their lives for their entire lifetime, and nothing bad ever happened to him. Caligula sort of comes to mind. Mm-hmm. He was assassinated, but he was a horrible human being. And of course, you know, do we want to mention that other guy we were talking about? It's a modern day example.
You mean Mango Mussolini?
Yeah. Yeah, that guy.
You know,
and there are people that have been absolutely wonderful human beings, you know, and they still had shitty lives. Mm-hmm. And that's because, you know, reality doesn't care. We care, you know, we can be nice to nice people, and we can be, you know, we can try to take down the bad people. But, you know, the universe and physics, for that matter, doesn't make any judgments about any of that.
Well, I would say karma does come back, but that's what I named my boomerang. So that's why it comes back. But, okay, so I guess let's make a distinction here. So let's start with maybe a definition, an oversight, maybe simplification for those of us idiots like myself. What exactly maybe is, let's start with physics. Let's start with just like plain physics.
Okay.
So how would you explain physics to somebody who doesn't know what that is?
Well, typically when you start talking about physics, like if I were teaching a general physics course or something, mm-hmm. we'd probably start off with Isaac Newton. Isaac Newton was freaking brilliant. You know, mm-hmm. it's passé now, but, you know, they talk about rank 1 geniuses, rank 2 geniuses, things like that. Newton and Einstein were rank 0 geniuses by pretty much anybody's assessment that you know, is qualified to assess that. Newton came up with a whole bunch of stuff almost just out of thin air. I mean, he used experimental observation or whatever, but he came up with a whole lot of stuff that just nobody, you know, fully grasped prior to him coming along. And all he did was he applied math to observations of the world. He came up with the theory of gravity. He came up with mechanics, F equals ma, force equals mass times acceleration. And he built on that. You know, concepts of kinetic energy, concepts of momentum. All of these things spun off, if not were absolutely authored by Newton in the first place. This is math applied to the world and making predictions. If you build a rocket and you spew gas out of the back end of that rocket, you're going to be able to predict how much that rocket's going to accelerate in the other direction, depending on the speed of the gas you throw out of the back of the thing. And you'll know whether you can get far enough out of the gravitational field or get enough velocity to go into orbit or not, or whether the thing's going to go up a few feet and fall back down and blow up and bad things are going to happen. Mm-hmm. So Newton, you know, I almost call it applied mathematics is what Newton did. Applied mathematics, a mathematician hearing that might get upset with me because that's actually a field of math, but that's what it is. He learned to think in a more rigorous way so that we could solve problems using math and make predictions. And, you know, he taught the rest of us how we could do that too.
Mm-hmm. You think if Newton had not been there, you think it would have taken us maybe speculation, but do you think somebody else would have came down the line eventually and figured it out? But maybe not
eventually, or it might have been, along with the term eventually, we might say that it might have been 4 or 5 other people that found bits of it here and there mm-hmm. until it finally got consolidated into a larger whole.
Yeah, Newton certainly was quite a character by himself. I mean, didn't he just invent calculus on a dare or something like that?
He actually needed the calculus to do some of his own equations. But yeah, he pretty much invented calculus.
So he was no dumbass, that's for sure.
It's so funny. I mean, the story behind him is fascinating because, I mean, he was like, let's say, a sophomore in my mind just went blank. My brain just took a trip to the Bahamas there for a minute. Oxford. He was a sophomore in Oxford, and it happened about the time the plague hit. So they sent everybody home, so that people didn't die from the freaking plague. And so he's hanging out in his daddy's barn. I mean, this is colloquializing it a little bit, but he's hanging out in his daddy's barn, just to have something to do. And he's doing experiments with prisms and lenses. And so he comes up with theories of light and color. He's playing with, pushing things around. So he comes up with the whole force thing. And he comes up with a theory of gravity, all because he was told to go home from school and just think for himself for 6 months, while the plague passed. And while he was at it, just so he could explain things better, he invented calculus, to do it. That trivializes it a little bit, but you read the story, and that's not too far off the mark as to what the guy actually did.
So indirectly,
got two ideas from the local college, and then he just went off and played in his garage and came up with all this shit.
So indirectly, the plague gave us calculus and gave us the theory of gravity.
Yeah. Yeah, if I understand the story correctly, it's been a while since I've read it, but yeah, that's kind of true.
You think they say Isaac Newton also was not didn't have a relationship with women and all that, so I guess he was like the modern day, the ancient day version of a nerd, really, experimenting. So you think if Dungeon and Dragon had existed back then, we wouldn't have calculus today?
Oh, that's entirely possible. If he had other outlets. If he could have gone and played video games, sat in front of his Xbox for hours on end, absolutely. Exactly.
So Newton is responsible for a lot of the physics that we have today. But exactly how do we define physics as per se there?
Well, physics is actually hard to define. Last time I even tried to look it up, like in the World Book Encyclopedia, they said, well, there's 5 major divisions, and then they tried to tell you about thermodynamics. They tried to tell you about mechanics, and again, there's 5 major divisions, but there is some commonality. The commonality is applied math. It's trying to take mathematics and model the world around you and understand the real world around you by using mathematical models and then using the predictive power of those models. This is where it all started. I mean, modeling's now moved on to meteorology and stuff like that. Of course, now we use computers. We don't just do it by hand, with simple formulas anymore. Very often, lots of those computers still use differential equations and things like that, which, again, goes straight back to calculus and the fact that Newton sort of invented calculus pretty much on his own. But it's really, if you want a simple definition of physics, it's attempting to understand the world around you through mathematics. Okay, that's the best definition I can give you.
And the five different categories of physics, briefly, let's bullet point through them, would be?
Oh hell, man! You expect me to remember? One major branch was considered to be mechanics.
Yes.
Which of course is we're not talking about working on a car engine. We're talking about you throw a ball, how does it fly through the air? Or you push on something, how does it move when you push on something? So mechanics on that level. One was thermodynamics, they claimed. One was maybe physical chemistry or something like that, where you actually talk about physical processes in chemistry. One was probably atomic physics, and one was probably nuclear physics, which of course deals with how atoms work and interact with one another, and then also deals, if you go to nuclear, how the internal structure of an atom holds an atom together and makes an individual atom work.
Okay.
So let's say for the sake of argument that those were the 5 things they listed as the major branches of physics.
Yeah. Okay, fair enough, fair enough. So now you get all these forces, and of course you're using applied mathematics to explain with numbers exactly what is going on whenever a physical event happens. And this is an explanation that we have for the physical world.
Right.
Okay, so now, of course, the word
and now
quantum.
we're good for 300 years.
Yes. And then, of course, the word quantum physics comes in all of a sudden. And now that is a whole new ballgame.
Right. And now we finally get to basically the turn of the century in the 1900s, where we're starting to get a handle on a lot of stuff and understand how the world works. But as our instrumentation gets better and as our experiments become more refined, we see weird stuff that we just can't explain.
Like Deepak Chopra.
Again, pardon me?
Like Deepak Chopra.
Yeah, well, not like we certainly just didn't sit around and think happy thoughts and figure, oh, that's how the universe works.
No, but you just saw you started seeing weird things we couldn't explain. I thought Deepak Chopra was one of them.
Oh, well, that could be. Yeah, I could say that. So again, when you describe this, say in a general physics class, usually the example you hold up is the photoelectric effect. Hey, this is where things start to get weird, and it's fun to talk about this. It's fun for me. You guys might be bored as hell. I don't know.
No, but go ahead.
Basically, they hooked a battery. I'm going to simplify this as much as I can to you. They hooked a battery to a couple of metal plates, and then they shone light on one side of these metal plates and started knocking electrons off of one plate. And the voltage across the two plates was enough to accelerate that electron and make it run over, and you get a current. And that was pretty cool. You shine a light on this giant capacitor-looking thing that's hooked up to a car battery, and you can actually read a current going through it and shine light on it. And you think, well, all right, that's cool. And the more intense light you use, the heavier the current is. The more the higher frequency light you use, the lower the voltage can be, or you can even go in the opposite direction and use a negative voltage, and it'll still have enough energy to knock the electrons out of one plate, send it off to the other, and you'll still get a current. Now, there's nothing wrong with that on the surface. It all kind of makes sense. You've got these light beams coming in and knocking the crap out of the electrons on this plate and causing current to flow, even though, this thing is not physically connected. So there's no wire running from one terminal of the battery to the other. That's the photoelectric effect. Here's the problem. The problem is that everybody at this point thought that light was waves. Mm-hmm. You still with me?
Yep.
Okay. So everybody at this point thought that light was a wave phenomenon. It was just electromagnetic. It's just an electric field and a magnetic field en masse, radiating out from some antenna somewhere, and this wave would come in and crash on these plates, and that's the end of it. Why is that the end of it? Because if light is a wave, then it doesn't have enough energy at any single point on that plate to knock an electron out of that atom. And the guy that actually did the experiment said, I don't know what's happening here. So this young upstart comes along and he says, well, you fool, there's this guy named Planck over here that has been working with a different problem, and he explains this perfectly. If you think of light as being little particles, so they're little concentrated points of energy that are coming in and hitting this plate and knocking these electrons off of individual atoms, then it makes perfect sense. The higher the frequency, the more energy the electrons have, and the higher the voltage they can fight. The more intensity, the more electron flow you're going to get. If you just think of light as tiny little particles smacking the hell out of this plate, then it makes perfect sense. Well, yeah, okay, that makes perfect sense, but that's not how we think of light. Now we run into a problem because there's so much physics for that first 300 years that I mentioned, that I alluded to, that treated light like it was a wave, and everybody was happy with thinking of light as a wave. Now you've got this new equipment, this new experiment using new stuff, and thinking of light as strictly as a wave doesn't work. you'd never get any current flow like that. So now you have to think of light as a particle. It's called, and it's actually called wave-particle duality. That's how it's addressed. If you look in a physics book and you know what chapter you want to go to, it's wave-particle duality. So now we have situations where waves act like a particle. They act like little packets of energy coming in and acting on something, and behaving differently than just being a wave, like an ocean wave hitting the shore. If that wasn't bad enough, it doesn't take much longer for somebody to come along and say, shit, under the right conditions, particles act like waves too. So things we think of as particles, like electrons, you do the right stuff with them, they start acting like they're waves instead of solid particles.
Okay, so let me...
By the way, you know who that young upstart was that says, if you just think of light as packets, it's all good?
No, who would that young upstart be?
That was 1905. That's a clue.
That'd be Einstein then.
That'd be Einstein.
Mm-hmm.
And the other interesting piece of trivia that I always like to inject here is Albert Einstein actually won the Nobel Prize for the photoelectric effect. He never won the Nobel Prize for relativity.
That's interesting.
General R. Special.
That's interesting.
So, yeah, he actually won his Nobel Prize for explaining this phenomena.
So I just want to recap here to make sure that I've actually understood this. So we have Newton that comes in, and he explains using mathematics what goes on with everyday movement and force and everything like that. And we have these formulas for quite a while, and everything's being explained. But now, as instruments are getting better, technology is getting better, we're starting to see things that don't quite fit the mathematical models, essentially. Right? So we're trying to refine the formulas, but at this point it's getting too weird that we need to open up a new category, and this is what quantum physics essentially is.
That's all correct. That's a good recap of everything.
Okay. Now, my second question is, now you were talking about lights being a particle and a wave. Now, is it possible, in my stupid little mind here, that there could be a third option to this? Because we think it's either a particle or a wave. Could there be another status, another way of being that is not a particle nor a wave that we don't understand yet?
Yeah, okay. Absolutely.
Okay.
I don't know what that thing would be because I'm not smart enough to think of it. But yes, when you can look at a wave on the ocean and you can explain its behavior and or a sound wave, and you go, okay, we fully understand this phenomenon. And you can look at a particle and you can talk about momentum and how it can transfer energy from one thing and another when it bounces off of it. And you call that mechanics. You can understand that and you go, okay, we understand that phenomenon. Mm-hmm. When you get something that's in between and they're both things at once, or acts one way when you observe it a certain way and then acts the other way when you observe it a different way, then you can say that it's a sort of an admixture of those two different functions that you understand, or you could say it's something completely different. Mm-hmm. The way we understand it is saying that it's a mixture of those two functions, but it could be something completely different that's neither particle or wave.
Yes. Okay. Perfect.
We'll need our next Einstein to do that one for us.
Well, yeah. No, I'm certainly not him. I just had that thought all of a sudden. We look at it as a duality, but what if there was another explanation we just never thought of? Sure. Instead of a particle or a wave, could it be a spray or I don't know? Anyway. Thank you for answering that. So let's get back to where we were there. So now we've got these phenomenons that we're not quite understanding with Newtonian mechanics, I guess, or Newtonian mathematics. And we have this new category, and we call them quantum physics. And then what?
Well, and so the other point I was going to make quickly was you got to remember you're going back, I think it's 400 years when you're talking about Newton. Mm-hmm. So he's a dude in a garage or a barn, right? And he's pushing blocks around on the table, but he's dealing with a macroscopic world. He's dealing with the stuff you and I get to interact with and play with every day. So he's dealing with the stuff that we're used to. As the equipment gets better and as we do more things, I mean, even space travel, right? As we do more things, we're pushing the envelope of what we consider to be normal life, normal energy ranges, normal speeds, how big of an object you're used to playing with. Before microscopes, you didn't play with anything or know anything about anything that was, smaller than a gram, say, of material. So you're pushing down into the microscopic world. You're having instrumentation that now is sensitive to stuff on the microscopic level. That's the first time that ever happened, was in 1900 or so. So part of why this stuff seems so weird, whether you're talking about quantum physics or whether you're talking about relativity, is it explains effects that happen on scales that we don't deal with in everyday life. That's why it's so weird to us. If you're talking about relativity, it's effects that happen at speeds or under gravitational fields that we're not used to dealing with. I mean, we don't have a black hole sitting, in orbit around us. So we're not used to dealing with, the intense gravitational fields. We're not used to dealing with traveling at near the speed of light. So the fact that things behave differently under those conditions, it assaults our sensibilities, but there's no reason it really should. It's outside of our normal everyday experiences. That's the only reason we have a problem with it.
Yeah, it's also the reason why we have a hard time understanding it, because we can't really relate to it.
Right.
Yeah.
And that's also what makes it fun.
But at the same time, these phenomena, although they can be on a very tiny scale or a gigantic scale, do have an effect on our world nonetheless.
If we can find a proper way to amplify those effects and make use of them, absolutely. Quantum computers are just around the corner, so
okay, you gotta explain that one to me, because I hear that I can't wrap my head around the quantum computer.
I'll try to do that in a nutshell.
Okay.
I have a whole talk that I gave. I'm going to warn you up front. I have a whole talk that I gave at the last con that I went to on quantum computers. It was a 50-minute talk. 6 people showed up, and 3 of them left before I was done.
Oh, no. Jeez.
To my credit, it was a con, and people like to drink and have fun at cons, and it was on Saturday night at 10 o'clock.
Okay.
So, I mean, people got bored. They left to go drinking or whatever, but it's hard to boil down in a way that people go, oh, yeah, that makes perfect sense, in 5 minutes or less. And that's part of the problem with pop science stuff and hard concepts in physics is you really can't do them justice in 5 or 10 minutes. And let's face it, that's what most people's attention span will allow.
Yeah. But if it's any consolation, those 3 guys that stayed for your conference there for your explanation are the same 3 listeners we have for this show. So that's pretty good. We're in familiar territory.
So the same 3 people that you have for the show then are my wife and the 2 directors who didn't want to walk out and leave me in an empty room then. And one other random person that I didn't know personally, so I don't know who they are. But quantum computers.
Yes.
You can do some really interesting things with them. When you take the standard digital computer and you do math with it or you handle information with it or whatever, you've got a transistor. And when the transistor's on, you call that 1. And when the transistor's off, you call that 0.
Yes.
Right? Standard digital electronics, that's the setup we've understood computers under, in the pop science world. We're trying to shorthand that, for 40 years now, right? 1 is on, 0 is off. It's a transistor, and that's what makes up a bit in a computer.
Yes.
And by manipulating these bits, you can count, you can do math, you can track data, all that. So enter the qubit, which is the quantum bit in the quantum computer. The qubit is this thing that you can turn on and off simultaneously. Its on state and its off state happen at the same time. It is what's called a superposition of states. And to make it better, this qubit and that qubit next to it can be coupled together in one way. So when this one is on, the other one, if you measure this one in some way and you force it to be on, then the other one is automatically in an off state. if it's coupled that way. Or it could be coupled another way where if you check one and it turns out to be in a known state, then the one next to it is also in a known state. So it becomes this thing that is not fully defined, and you can do interesting mathematical tricks with it. What kind of interesting mathematical tricks? Well, the soundbite that I always use on this is I've programmed computers for 20 years, and I know that I know how to tell a computer, turn this byte on. I know how to tell a computer, turn this bit off. What I don't know how to tell a computer or how to even program is, I don't know whether that thing's on or off. Just take your best guess and move forward. So that's what you're doing sort of when you program a quantum computer is you're saying, I have this thing that I'm trying to represent. I don't know what the numbers are, but as time goes by, you figure it out for me. And the computer will go, okay, I'll do what I can. So the best analogy that I can use, again, in our normal realm of life is intuition. It's almost like you're learning how to program a computer to intuit data, like a human might. And even though you don't have the full picture and you can't fully define, a system or a process, you tell this thing, I don't know what the hell's going on, you figure it out, and it'll start cranking the numbers that it knows, and then it'll intuitively come up with a solution for the bits you don't know.
Okay, that's weird. Oh, I gotta stop you there. Okay, I gotta stop you. Okay, so
I stopped myself because I figured you'd have some follow-ups from there.
Yeah, well, this is what I'm trying to picture here. Okay, I'm a very visual kind of guy. Okay, so I'm picturing the traditional transistor, right? You're sending a current. Now, the current, if you send the current in, it flicks the switch either on or off. Okay, so that's very straightforward, and this is how it basically works. Now, I'm trying to figure out how if you have your quantum computer there, and you have your other, did we call it a bit? What do we call it?
A bit, a qubit.
Your qubit. Okay, you send your qubit. So I'm assuming you're sending a current as well through it.
Well, let's go one step further with this. Let's say it's an optical computer, and let's say that it's like a little window. That little window is actually an atom. Okay. And you shine a laser light on it, and sometimes when you shine the laser light on it, it goes straight through, and you see it on the detector on the other side. Okay. And sometimes when you shine a laser light on it, it gets blocked, and you don't see anything on the other side. Okay, so that's your 1 and your 0. Okay. So now you've got an atom that's sort of on and off at the same time, and you don't know what it is until you shine this light on it. So you can't just look at it at any random time and it be in the same state that it was in when you looked at it just a second ago.
Kind of like Schrodinger's cat.
It's exactly like Schrodinger's cat. This is the type of effect that led to that whole discussion about Schrodinger's cat, even back in the 20s or 30s, whenever that happened.
So instead of having like copper wires and to put an electrical outlet, you're playing with atoms at this point here, and you're shining lasers onto atoms and creating an effect.
Well, actually, that's not in effect. That's what's happening. They actually, the quantum computers they're building right now are isolated atoms or isolated collections of atoms, and they're super cooled down to like 0.7 degrees Kelvin, so almost absolute zero. Jesus. Because, you get thermal effects, all the stuff goes away, because you're looking at an individual atom, and you're trying to measure the state of that individual atom. And you're using the quantum fluctuations in that atom to do calculations.
It's almost as cool as my ex-girlfriend.
Yeah.
Well, this is a naive, practical question. Are these computers expensive, and are they in most major universities, or are they rare around the world? What is their status?
You could almost, these are like the Cray supercomputers back in the 60s. You could almost count on both hands the number of them that there actually are that work.
Oh, they actually do exist at this point.
They do exist.
Oh, wow.
They've been proven theoretically to work, but they're far from ubiquitous. As a matter of fact, because of the fact that you need to cool them to such low temperatures, I can't imagine you ever having one like on your laptop, right? And how much do they cost? Hundreds of millions of dollars.
Okay, so this is a question of time before the technology gets better enough so they can shrink it down to something more manageable, the same way the original computer was the size of an entire room.
Correct. And it's important because, we're coming up against the limits of digital electronics.
Yeah.
And this is fun to talk about, too. We keep doubling the size of the chips. It usually doubles every 18 months or so. And by doubling the capacity, I should say, not the size, the chip size remains the same. By doubling the number of transistors in the chip, they become denser and denser. Mm-hmm. And the little wires that connect all those transistors together now are so close together that we're hitting a physical limit. We're getting to where Moore's law is about to break on us. We can't cram any more transistors onto that chip because literally the electrons that are going through those wires to those transistors are tunneling from one wire to the other, which is a quantum effect, by the way. Mm-hmm. So now you can't make these transistors on these chips any denser, or very quickly we're getting to that point. They're already having to do tricks to increase the density, like add multiple layers and stuff like that. Now you're getting to the point where quantum tunneling, electron tunneling between the wires is making it to where you can't make the computers any smaller. Wow. They end up generating their own noise and they don't work. So this quantum computer is the next step. It's a way to increase computing power, by using a different technology, because we're about to hit the limits on the computing power as far as digital electronics goes.
Now, this is a silly question, but is there an actual practicality having these quantum computers? Because let's face it, I mean, if we're exploring the unknown, I could see that, like in the realm of pure science. But for the everyday person, is there an actual need, or do we actually see that as a viable product down the future? Because, I mean, does a person really need to have a quantum computer to do their everyday life thing?
I am glad you asked me that question, Kevin.
Geez, once in a while I do ask a good question.
So, what good are they? This fuzziness, this whole intuition thing, what does it do for you? One of the big things that it does for you, if you're the government, for example, or is certain corporations, for that matter, it's cryptology. You can give it a 32-bit encrypted message, and it might take a digital computer more than the lifetime of the universe to break that encryption. Oh, wow. Going 1, 2, 3, 4, 5, 6, and just random, or not randomly, but just trying codes one after the other until it reads something sensible in that message. A quantum computer can take that same 32-bit encryption and decrypt it in, or break that code in, let's say, a second. So it's going to make it to where everything that's encrypted right now over the internet, in messages, whatever, is going to be easily broken if you have a quantum computer. Now, of course, it's like an arms race, right? If you've got a computer that can break that kind of encryption that fast, then you're probably going to go to a higher level of encryption, right?
Mm-hmm. Yeah.
But if you're a government trying to spy on your citizens, or looking for terrorists or whatever, it basically makes it to where it's trivial now for them to read our emails, no matter what level of encryption we put on it. So that's one use for it. Another use for it is really, really monstrously huge databases. If you've got a database with a record in it that you're searching for, and let's say there's a trillion records of data in there, it might take a regular computer going one step at a time, let's say 20 minutes to go through that whole database and find the record you're looking for. A quantum computer, you do a database search on it, and it might come back with the record you're looking for again in half a second.
Geez, I need one of those at work.
So it's funny because it's not faster. If you multiply 3 times 6 or 3358 times 496 or something like that, the digital computers are still faster. They'll do straight up math faster than a quantum computer will.
Really?
But when you've got that fuzzy element to it, where you're trying to solve, for let's say, 65 bits simultaneously, it can do that faster than a conventional computer.
So in a way, there might be a way where the original digital computer that we have now might never actually truly disappear. There might still be a function in the future for them to stay around, maybe just as pocket calculators.
Oh, yeah, absolutely. Again, I think for surfing the internet, the laptop, that you've got right now is probably still going to be good for, however long it lasts until it gets enough bloatware on it that you can't run it anymore.
Wow.
But even when you replace it, you're probably not going to replace it with a quantum computer.
Now, I did have a question. This is going back to when you have the quantum computers and how cold you have to keep it. Just for a reference point, how cold in Fahrenheit is 0 degrees Kelvin?
Well, in Celsius, it's minus 273.
Is it minus 273 in Celsius?
In Celsius.
Yes.
And I don't know in Fahrenheit, though.
I don't know in Fahrenheit either.
Okay, it's Celsius.
A calculator out to give you the answer to that.
When you do science, you're in metric, for Christ's sake. There you go.
Right.
Fair point. Fair point.
You don't worry with, nobody uses the English system but Americans anymore, right?
Yes.
Very true.
United States citizens.
Yeah.
It's like they tried to use the metric system one time in the States and said, no, we don't like this.
So, Ben, I want to take you, if that's okay, in an entirely different direction for a minute. With all of this that's going on, with all of the computers in the future, I want to bring you back to the present and ask you, what is the state of science education and physics education in the public schools today? And do you think that it's possible that the United States is up there in competition with the other countries of the world, or do we need to improve the way we teach physics, the way we present physics to men versus women, and just your whole thoughts on science and physics education?
You just opened a huge can of worms.
I did, but I know Ben is capable of more than that. So.
I think about this a lot. I think there are a lot of factors that come into play here. You want me to turn this into a rant, or you want me to try to stay calm and rational in my...
You be yourself, Ben. You be yourself. We love you.
I know a rant is more fun for you, so go for it.
Well, actually, the reason I rant is because I can usually sum it up a lot faster if I'm ranting.
Rant ahead, buddy.
Is nobody gives a shit about science in this country anymore. It's hard. You have to think. It takes concentration and effort. And it's much more fun to, talk to dipshits on the internet or play your video games than it is to actually think about science. So I think it's a losing fight in this country. As much as I hate to admit that, there's too many other stimuli out there, and there's too many other things that people want to do other than sit down and work a physics problem for an hour at a time. So it's not happening here. The science is going to get done by the people in India and Thailand whose parents actually give a shit about education and make their damn kids study still, because they see it as a path to a better life. And that's why all these people keep coming over from India and China and taking our jobs as scientists, because they're the ones that have done the work, and they're the ones that know how all this stuff works, where the current theories are. And, they're better scientists than we are in a lot of cases. And it's funny for me to say that, because I've heard Michio Kaku say the same thing, and it makes me want to kill him. Because there are still good American physicists, chemists, engineers, and like that. Anything technical you want to throw in there. There are still people from this country that do that. They've grown up in an environment or whatever where their parents have encouraged them. If they were like me, they went up and played with their little electronic kits, in their room by themselves for hours at a time, because that was more entertaining than watching TV with the family. So there are still people like that in this country, but they go to grad school, they go to grad school, they put in 24 years of education, and then there may or may not be a job for them. And if they're offered a job, it probably pays $30,000 a year or something. And again, if you look at that from an American point of view, And with American sensibilities, all his friends are going to look at him. All his or her friends are going to look at him and go, "Man, you're a fool. You invested $250,000 into your education, or $500,000 into your education, so that you can get a $30,000 a year job. You sit at the particle accelerator all night long and watch data come in. There's a much easier way to make a living than this." But somebody from China or somebody from India goes, $30,000 a year, that's more money than I've ever seen anybody make back where I live, and they think it's great. So again, there's a difference in perspective here. Americans are more than happy to sell insurance or make stupid YouTube videos or whatever, and make whatever they make doing that, $60,000, $70,000 a year, say. That's a lot easier path than actually having to learn and think and concentrate for half the money. You're actually, lots of people actually look at you like you're a fool if you do that here.
Wow.
And I don't know, maybe I am. I did get, I am semi-retired and have a pretty good life, at 54 years old. So it wasn't the worst career path, obviously, but it's not. There are easier ways to make a living. Even I have to admit that.
Yeah, I get that. Wow. Well, thank you so much, Dr. Ben, for all this wonderful, wonderful lesson we had today on physics and quantum physics.
Yes.
If people want to find out more about Ask Dr. Ben and everything else, where can they find you?
I've made it easy. The Facebook page is still the mothership. That's facebook.com/Ask Dr. Ben. But I also have AskDrBen.org. So go to that website, and there will be links to my presences everywhere else. My YouTube channel, my Patreon page, my Instagram, all that stuff. And, of course, the Facebook page where most of my postings go first.
Fantastic. Dr. Ben, thank you so much for all this today. But before I let you go, I got to have you say, hi, this is Dr. Ben of Ask Dr. Ben, and I took a left in the valley.
Hiya, this is Dr. Ben of Ask Dr. Ben, and I took a left in the valley.
Fantastic.
Did I do good?
Yes, you did.
You did fantastic.
And that was Dr. Ben Davis, the one and only.
He's great.
I love Dr. Ben.
I love Dr. Ben.
Another great lesson from Dr. Ben Davis. I learned a lot. I know that. I know that, if he can teach my dumbass, he can teach pretty much anybody.
The nice thing about it is that Ben is grounded, and he realizes that most people don't operate in the theoretical. So he keeps everything manageable so that you're not overwhelmed by things that you don't understand, but he takes things that you do understand and just builds on them a little bit at a time, before you get lost.
What I find, when we talk about science like that, what I find that's a bit of a problem is, there was a time slightly before me, where the United States represented hope for the future. People were excited about the space race. They were excited about, remember they had these awful magazine articles about the car of the future, the house of the year 2000 and all that stuff. And it was hope for the future. And then Ronald Reagan came in.
I think that was probably
around that time.
Yeah.
And of course up here was, and I've said this before, it was Mulroney up here and Thatcher in the UK, and all of a sudden we did this horrible detour to conservatism where greed is good, make money at all costs, and it's all that mattered ever since. I want to go back to the time where we hope for the future. This is where we need to go. And this is where science can take us. And this is why it's so important to go back into this love of science and love of experimenting, and to be the explorers that our species is so good at being, instead of being the money makers. God damn it, what is wrong with us as a species?
Yeah, I think the point that Ben was making was that there's plenty of money in the education, but not in the applicant. Where are the jobs?
Yeah.
And that's what we're talking. You have people with all of this knowledge that are ready to explore, that at a moment's notice, could do the invention and the creative thinking, but the job availability is so low.
This is where I'm also hoping for the future, because in a way, we've talked briefly about this before, automation is on its way. And there's a lot of jobs that are going to disappear in the near future. And at the same time, we have to start rethink our entire capitalist system. And if we go on something like universal basic income, that will free a lot of minds to pursue things like art and science. So I do hope that this is where we're heading, but time will tell.
Well, but there again, when you get to automation, you have to have the scientists that will take the equipment and put it into more... what am I thinking? They're going to have to create more jobs. They're more technical jobs and more creative jobs, so that the automation doesn't take jobs away from people, but it gives opportunities to those who have a scientific ability.
Yes, absolutely. Perfect. Well, thank you so much, my dear Nancy. That was great. That was a great show.
Yeah, it was. Just like always. Yes. That's our normal.
Yes, it is. And thank you for listening. And thank you to Dr. Ben Davis for being with us today.
Absolutely.
You can find us at left@valley.com. You can find us on Facebook, on Twitter, at LETV Podcast. You can send us an email at left@valley@outlook.com. You can send your complaints to Nancy on the 3rd floor, but beware of the incoming knife. If you really like what we're doing, you can be like one of our friends like Freethinker215 and support us on Patreon/LETV. Give us a 5-star review wherever you find us. It really helps us and helps others find the show. Okay, coming up next week, we were supposed to have Andrew Jasko, but he had to bail out. But we still have Rex Burke. I'll be coming to us, and we'll be talking about cults. So he was part of the
that's always a good topic.
Yes, we'll have Hertzie Hertz of the Minnesota Atheists. I'll be talking to us. Our friend Lilith Starr, who wrote a book, the Satanist Lilith Starr. She wrote a book, and we'll be talking to her about her book. And then, of course, July comes in. We'll have our Canada Day special. That should be fun. We'll also have the Ginger Snaps with Amy Cool. That'll be fun as well. And we'll also have our old friend Andrew Torres, lawyer Andrew Torres, is coming back. He'll be talking to us about all the mayhem that's going on in the States with the whole abortion issue.
Oh, man. The timing should be so perfect.
Yes, so that'll be fun to do, for sure. And, of course, somewhere down there, we should try to have Matt Dillahunty back as well.
Yeah, absolutely.
Perfect.
Yeah.
Anything else I need to add?
Oh, lots of good stuff to look forward to.
As usual.
Yeah.
Excellent, my dear. Until next time.
God made me skeptical of anything that contradicts history, denies evolution, hates science, promotes mystery. I'd rather see the truth than to bask in my own ignorance. Rather be alone than surrounded by damn idiots. As long as there's a breath in my body, you can bet your last dollar I'll be working hard fighting this problem. Religion is a disease, it comes from culture, only true on a regional scale. Science is universal. Are you to say that Horus isn't real, but Jesus is? Or Zeus, Thor, Mithra, Vishnu, you don't believe in them? I think the reason is apparent. You do what you're told and believe in the God assigned by your parents. I'm proud to be an atheist, a skeptic, a non-believer, an infidel, a heathen. I call it how I see it. I say it's ignorance and you just call it faith and unsubstantiated claims. That's something to be ashamed. I'm an atheist. Atheist. I'm an atheist. Atheist. I'm an atheist. I'm an atheist. Now let me take a sec. Don't mean to sound so hateful, but I swear to God, pun intended, I find it disgraceful that thousands of children are raped by priests, and since they're holy men of God, they get away scot-free. And the Pope does his very best to keep it on the hush. Don't wanna affect business, he loves money too much. We know that they love the kids, but how the fuck can we protect them while they planning to molest them? We teaching them to respect them.
Fuck that.
The system is broke down, working backwards, and the only action or tactic I plan to practice now is to attack them. The parties of God's hands are bloodstained, millions of murders by believers, and they're all in God's name. And let me take a sec, don't mean to sound so hateful, but I swear to God, pun intended, I find it disgraceful that many atheists are told to be quiet. You're not alone, speak your mind, time to let it be known. I'm proud to be an atheist, a skeptic, a non-believer, an infidel, a heathen. I call it how I see it. I say it's ignorance and you just call it faith and unsubstantiated claims. That's something to be ashamed. I'm an atheist. Atheist.